Okay, so this is your review for your Chapter 5 test tomorrow.
Would this be sides?
First thing, let's everybody write down what you think these answers are. Classify each triangle by its angles and its sides, please. Angles and sides. All right, so the angles first, we have acute, and then one obtuse. So let's make sure we understand something. In every triangle, two of your angles are going to be acute. In every triangle. A right triangle, the other two are acute. Obtuse triangle, the other two are acute. In an acute triangle, all of them are acute. So in every triangle, two of them are acute. So you're looking for the third angle to decide what the side length should be. So that's acute, and then we have 114 degrees. So by definition, this is obtuse. Okay, the next thing you look at is their sides. All right, now you have to look to see if sides are the same. If none of them are the same, it's scalene. If two of them are the same, it's isosceles. If all three are the same, it's equilateral. So that's what you need to look for, and you need to know how to spell. I'm not going to count it wrong, but learn how to spell. You're in high school. So we see that we have 2.2 and 2.2. Those two sides are the same. 3.7 is not. So you have two of those. Okay? So 2 means isosceles. If you want some help, say it isosceles. That'll help you remember the letters. Okay? Okay, again, number 2. You have your two acute angles, and you're left with a 90-degree angle. That means you have a right triangle. And then 11.7, 4.4, 10.8, none of them are the same, so that is scalene. We have a right scalene triangle. So your test has that on it. Make sure you know these names, okay? Spell them correctly, please. Okay, find the measure of each angle indicated. So number 3. Okay, find the measure of each indicated angle. So the triangle sum theorem says they all add up to 180. So you take 180 minus 125. So that's 55. Minus the 21. That's 34. So 34 degrees must be the last one. All right, everybody, solve for x. Okay, so triangle sum theorem is, x plus 46 plus 85 plus 55 has to be equal to 180 degrees. Each of those angles add up to 180. So 46, 85, and 55. You can subtract them separately or add them together and then subtract the total. So 46 and 85 is 120, 131, and 55, 46 and 85. It's 120, 131, that's 186. Subtract 186. X equals negative 6. So the only way this works is if x is negative 6. Otherwise it can't add up to 180. All right? So find each of the angles it's asking for. So there's a question mark on R. You have to find R. So just so you understand, you have an exterior angle, so you need to know the exterior angles theorem. Exterior angles theorem says that your exterior angle is equal to the other two angles added together. So angle S plus angle R. Not the angle attached to it, not angle T. Don't ever use angle T unless you have to find the other two. Okay? All right, so exterior angle equals the other two angles added together. Okay, your exterior angle is 61. Angle S is 29 degrees. And angle R, we'll just say is X. You can leave it as angle R if you want. Now we subtract 29. It just becomes algebra at this point. Okay, subtract it. X is 32. So angle R is 32 degrees. Another way to do this, for this problem, it can be done a second way. You have a straight line, that's 180 degrees. So those two are supplementary. So angle STR is 180 minus 61, or 119. And then you could use the triangle sum theorem to figure out angle R. So it doesn't always work like that, especially if they give you a variable. You have to know the exterior angle theorem at some point in time. Okay? Number 6. So a good example with variables. You could do it the other way too here, but try to use the exterior angles theorem. See how we did? So 100 equals 4x minus 3 plus 11x minus 2. So we don't need the parentheses. There's nothing to distribute. So we just put like terms together. So 100 equals 15x. Negative 3 and negative 2 is negative 5. All right, so add 5 to both sides. 105 equals 15. Divide by 15. And x is equal to 7. So it did say solve for x. And we're done. Be very careful. Make sure you answer what it's asking you to do. So it said solve for x. That's all you had to do. All right, number 7. All right, again, find the value of x. Now you have a puzzle, have to try to figure it out. What does all of the stuff mean? And everybody should be done by now. Here's why. If you know your theorems, you have your base angles theorem. Base angles theorem says if in an isosceles triangle, you have an isosceles triangle, that angle and that angle are the same. So x is 52 degrees. Same type of thing. Solve for x, please. 3, 2, 1. It's equilateral, so everything is 60 degrees. So x is equal to 60 degrees. Cake. Next. There we go, same type of thing. What is x? And 3, 2, 1, you should be done. All right, so this is the converse to the base angles theorem. If your base angles are equal, then the opposite sides are equal. So x is equal to 12. Number 10. So the reason you should know it already is you have an equiangular triangle, which means all the sides are the same. So x is equal to 10. All right, cool. Write a statement that indicates that the triangles in each pair are congruent. All right, so look at it, and you have to write the statement that is needed. All right, so the statement they're talking about is not why they're congruent. It's the 3 letters of each triangle in the order that shows that they're congruent. So you already have all the angles and all the sides there. All right, so you could use any of the theorems to say they're congruent. But it just says what's the statement. Here's what the statement is. So you have to decide which order to go in one triangle and then follow that same order in the other triangle. So if I said F, E, G, I better go the same direction in the other triangle. So F has the 2 arcs with it, and then it goes to 3 arcs. And then on the bottom triangle, F has the 2 arcs, and we go to the 3 arcs for the next letter. So F, J, and then to G. So then it's in the right order. Okay, so that's important that you can write that statement.
The lines are in different spots on the triangles. Or is it just matter that there's 2 of them?
Well, I was just saying I went from 2 to 3, 2 to 3 to 1. So 2 to 3 to 1 there. Okay, same thing. You could do it a different way, but the same thing with the hash marks. I have 2 hash marks here, and then 3. And up top, I went from 2 and then through the 3 to get to the 3 letters. Okay? That all this problem is saying, okay, do you understand that order is important in your letters? That's what this problem's about. And I've hit you hard all semester about it. So make sure you have the right order. Okay? All right. If it says write a statement of congruence, then that's all you need. Okay? If it says prove, then you got to show all that other stuff. So again, this is a picture of 2 triangles that have everything. All the angles, corresponding angles are congruent. All the corresponding sides are congruent. So write the statement of congruence, just like what we did in the last problem. So everybody write that down in whatever order. Everybody start with, I'll give you the first one. Okay? So triangle STW. What is that triangle congruent to? All right, so you should have said, let's see, STW. You should have said YXW. We started with 3 arcs. There's 3 arcs. We went through the 2 hash marks, so that tells me I'm going that direction. Statement of congruence. All right, so if that's on the test, that's what you do. All right, number 13. All right, complete each congruent statement by naming the corresponding angle or side. So this has everything to do with the order again. So the corresponding side that it's talking about. So the first thing you do is you look at the order of what they gave you and look at what they have here. So you have XVW. So X is first, V is second, and W is third. So you need to match that in the other triangle. Oops. Okay. What angle? So since X is in the 3rd position, that's first. K is in the 3rd position, that needs to be first. The second, number 2 is V. It's in the 1st position. So that better be what's next as well. And then you have W here. W is in the middle position, so that should match the J. All right, everybody do number 14. Okay, should be done. S is in the middle position, so that's angle G. That was simple. All right, number 15. Determine if the 2 triangles are congruent. If they are, state how you know. So this is just like what we got done doing on your quiz. So everybody state whether they are or not. If you say no, you say not enough information. If they are congruent, you have to give all the reasons why and the theorem of why they're congruent. All right, so to refresh your memory, you should always be looking for reflexive properties, things that are on top of each other, parallel lines like alternate interior angles, corresponding angles, and etc. And then the vertical angles. Those are the things that we should look for. There are no parallel lines. There isn't anything on top of something else, so that leaves vertical angles. Do we have any of those? And yes, we do. So you could say we have vertical angles. If there's letters, you got to state what the angles are that are congruent. And then you say by side, angle, side. Do not say hypotenuse, leg. If this was 90 degrees, then yeah, you have hypotenuse, leg. But you don't have anything that says those are 90 degrees. So even though they may be 90 degrees, you can't prove it. So you should have said side, angle, and a side. Remember, the angle has to be made by the 2 sides if you're going to say side, angle, side. So same as the last problem. Look for all those special things and then tell me why they are or are not. Okay, hopefully by now you see this. We do have a reflexive piece here that's shared in both triangles. So reflexive. And again, if there's letters, you have to state what they are. So let's just say it was ABC here. You would have to say AC is congruent to CA, reflexive property. And then you have an angle, a side, and an angle. If they have the letters. Tell me what's reflexive. Okay? And if you're going to say angle, side, angle, remember the side has to be attached to both angles. That's the only way you can use those. All right? And if I can remember at the end of the chapter, or at the end of the review here, I'll try to go through each one individually to remind you what you're supposed to be looking for. All right, number 17. All right, number 17. Okay, so again, we have a reflexive piece here. And we have two 90-degree angles, so immediately we think hypotenuse leg. It's not always hypotenuse leg, but that's how we start. So we have a hypotenuse, and because of the reflexive part, we have the leg. So it's hypotenuse leg. On the quiz, I had quite a few students just say, hey, reflexive. That doesn't mean you have congruent triangles. Okay, so I mean, I can draw two triangles that have a reflexive side. They are definitely not congruent. Okay, you have to have the theorem that goes with it. Okay, so this is a hypotenuse leg. Okay, so how you determine if you have hypotenuse leg is you have to have, so hypotenuse leg has to have 90-degree angles, and you have to have a leg and the hypotenuse. And the hypotenuse is what students, I think, really struggle with. So we have a right triangle. Your hypotenuse is the longest side of your triangle. Hypotenuse is not attached to 90 degrees either. It'll always be the longest side in a 90-degree right triangle. So you have that, and then you have to have one of the two legs. Okay, if you have all three legs, then you say side, side, side. Okay? Number 18. Same thing. Go ahead and tell me what you think. Okay, so what I see here, and what you should always look for, is the reflexive properties, the vertical angles, the parallel lines on every problem. And not just in this chapter, from here on out. That's what you should look for. So we have the center line here. That's reflexive in both triangles. So right off the bat, you say reflexive. And since you have that, you can count it. That's the third side. So now you have side, side, side. But you can't say side, side, side until you tell me that you have a reflexive piece. All right, number 19. Okay, again. Tell me how. Tell me why. On this one, you have a side, you have an angle. So either you're going to have another side, which is next to it, or you're going to have another angle. So it's either going to be angle, side, angle, or side, angle, side. There's nothing else marked. So you need to look at both of those things. And of course, this middle piece is reflexive, which means you have side, angle, side. You don't have that angle at the bottom. All right, so these two are separate, so there's nothing reflexive in these because nothing's overlapping. And since nothing's touching, you can't have vertical angles either, or parallel lines. So when you don't have any of those things and nothing else seems to be working, you have to go only by what's being marked. You only have two things marked. You have to have three things for all of these theorems. So there's not enough information here. Okay, so they may be congruent, but you can't say they are. Okay, so not enough information. Well, okay, so let's go through what each one of these is. We'll start with that one. If you have two angles and a side, the issue is either you have angle, side, angle, or angle, angle, side. All right, so what do these look like? If you have angle, side, angle, this one's the easier one. The side has to be attached to the two angles, no matter where they are. So if I have these two angles and I'm going to use angle, side, angle, that means it has to be this one in the middle there. It has to be attached to it. If the angles or in different positions, again, it would have to be that one there, attaching both angles. It can't be, you can't pick another side. But if you had a different side with angle and an angle, if it was there, or if it was this side, these are both angle sides. You have an angle, and then the side. Angle, and then the side. So let's get something straight. You will never, ever have side angle. Ever. And I told you that when we were going over it, and I had a million of you write those down as possibilities. You cannot have that combination, two sides and an angle, unless the angle's in between the two sides. So if I have side, angle, side, that's the only way it works. I have an angle. That means it can't be that side there. It has, for side, angle, side, the angle has to be attached to both sides. So this angle right here is attached to this side, and it's attached to that side. No matter where it's at, wherever your angle is, it's the two sides that are attached to it. You have side, you have an angle, and a side. Now, let me address the side angle problem. The two triangles may be congruent to each other, but you can't prove it with side angle. Side. Now, I should pick this angle and do side, angle, side. But I don't have it. I have this angle. Or maybe I have that angle. They may be congruent, but you can't use side angle. It doesn't work. I showed you that it doesn't work. It only works sometimes. And since it's only sometimes, it's not a theorem. Okay? Yeah, because of the hinge thing. So, please stop using that. I mean, I've said it a million times. Don't use it. The only time that you have side angle is this. Hypotenuse, leg. There you have a side, and an angle. But the angle has to be 90 degrees. And if you tell me that that is side angle when it should be hypotenuse, leg, I'm going to count it wrong. Because hypotenuse, leg works every time because it's a right triangle. It has to be hypotenuse, leg. So if you have this picture up here, you say not enough information because you don't have a 90-degree angle. You can't prove it. They may be congruent. Yes, you may look at it and say, they have to be congruent. You can't prove it. That's what this is about. And then obviously side is you have all three sides. All right, and then the last picture here, I'll just put the answers to all those problems we just did to the review. Okay. But they should match what we've said. Notice number 20 was not enough information, is what we said. All right, that's done with the review. We're going to continue with the review in the next class. I'll just pick some other problems. This was an official review. That's 20 problems. There's more problems on the test. So you need to make sure you're practicing other things. So I'm going to continue in the other class with other problems. Yeah, let's do a parallel. Let's say we have a problem that looks like this. These two lines are parallel. The second you have two parallel lines, this is what you should do, okay? Put your two parallel lines out like that. And let's use this first transversal, okay? In that transversal, angle 1 is right here. Angle 2 would have to be right there. Think about it. You have this transversal, those two parallel lines. So these two pieces I have in the correct positions over here. So what do you know about those two? Right here.
They're corresponding.
Corresponding means you're on the same side of the transversal. These are alternate interior. So at that point, you could say these two are congruent, alternate interior angles. All right? And then you have two parallel lines cut by this transversal. So angle 3 and angle 4. I'm picking the angles that are inside my triangles. That's where I'm getting these, okay? So where are they at in this picture down here? Angle 3 is right here. That matches your triangle. And angle 4 at the bottom would have to be right there. And those are alternate interior angles. Okay? So those would be congruent. You also have vertical angles, so that, okay?
So
But that's,
really, that would be a problem, parallel problem where you can't use anything else.
no, corresponding angles. In one of the homework problems, you had a corresponding angles problem. I think it looked like this. It was, I think, like that. So these two were parallel. So you have parallel lines cut by this transversal right here. Well, that angle is in that triangle, which matches that angle. Those are corresponding angles. They're not alternating around the transversal. So there you would have to say corresponding angles theorem. That's why they're congruent. That's great question. Good review for parallel problems. All right, so you have parallel lines. So cut by a transversal. I'll kind of say the same things I said in the previous slides. Sometimes it's good to draw the parallel line separately with the specific transversal you're looking at, or extend the lines. All right, so you only have two things in both triangles. There's not enough information.
Were you asking if the lines were parallel?
No, it tells you it's parallel. I didn't record any of that. Okay, so you have two pieces. You need three pieces, and you don't have it. All right, next. Let's do a couple of these problems. Okay, stop. Okay, so the long way, the triangle sum theorem says that the interior angles add up to 180.
That's it.
So you take 180 minus 86. What do you get, Garrett?
6.
Bro.
180 minus 86.
106.
No, it's 94.
94.
And then subtract off the 46. What do you get, Garrett?
48.
Okay,
You said 80.
so 48 goes here. And you have a straight line, which makes those two angles supplementary.
Okay.
So you take 180 minus the 48. And what do you get, Garrett?
132.
Yeah, so this is 132 degrees. Now, that's doing it the long way. Exterior angles are equal to the opposite two angles added together. Isn't 132 the same as those two?
Yeah.
Okay, that's the exterior angles theorem.
That's what I meant.
So that's all you have to do to
Yeah,
get
that's
X?
it. I did.
Maybe I'll remember that.
All right, let's try this one. The exterior angle is 9x plus 9. That's equal to the opposite two angles added together, 45 and 5x. All right, so the exterior angle is equal to the opposite two angles added together. So now it's an algebra 1 problem. Subtract your 5x. Subtract 9. What's 45 minus 9, Cooper?
45 minus 9. I can't do that.
36.
Thank you.
Divide off the 4. X is 9. So be very careful on the test. I'm not hinting, I'm just saying this. Make sure you answer what it's asking for. If it said, how much is the exterior angle, and you say X is 9, you miss the problem. Because that's just what X is. You'd have to substitute it back in.
Wait, is that on every problem?
You just have to look to see what they're asking for. If it just says solve for X, then you were done at 9.
Okay.
okay?
And
Yes.
you did that by the exterior angles, some
Theorem, yes.
Okay.
Okay, so if I have something like this, and was that an angle or a side?
There's a side.
Okay. And it did give you the sides, it just gave you the two angles?
That side's 12 and that one's X.
Oh, so like this was X and that was 12? Or vice versa?
Yeah.
Okay. All right, so let's do that again. So it gives you those angles, X and 12. All right. This is the converse to the base angles theorem. If you have two angles in the triangle that are congruent to each other, then the opposite sides are congruent. Converse to the base angles theorem. So that means X has to be 12. So you have to know your theorems. So at the end of the chapter review that's on here, I went through each type and what you should look for. So I'll mention that again as we do a couple of these problems, okay? Separately, they're kind of simple, but I think it's really the angle side and the angle side angle one, and maybe the side angle side one that's the problem. So let's take a look at two triangles. They appear to be congruent.
They do not look good.
That's why they appear.
Okay, so what you look for, you have all these different possibilities: side, 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 side angle, side, angle, angle, side, angle, and hypotenuse leg. So you do, each triangle has three things, so that's good. You have an angle, you have an angle, you have a side, an angle, and a side. The only way it could be side, angle, side is if the angle is in between the two sides. Well, you don't have two sides, so right off the bat, those two are gone. Hypotenuse leg has two sides, the hypotenuse and the leg. So it has to be one of these two. Now the question is, angle, angle, side, and angle, side, angle. The easiest one is if the side is in between the two angles. So angle, side, angle means the side has to be attached to both angles. Is the side attached to both angles? No. So in both triangles, it's that way. So the only thing left is angle, angle, side. But be very careful. Let's say I didn't give you that one. Let's say I gave you this one. And I said that. Please say no. Okay.
Not in a bimbo.
Visually, it's not right. Okay. They may be congruent, but obviously this little side is not the same as that side. Okay. So that's not right. All right. So let's do another one.
So if you gave us that same.
Okay, so you have these. I don't have letters on here, so you can't tell about the order. If there's letters on the problems, make sure you have to add something to the picture, that you have to use letters to explain what you did. In this case, are these two triangles congruent, and how?
Yeah.
Yeah, angle, side, angle. There's no reflexive. Reflexive means it has to one on top of the other. Okay, so you have angle, you have a side, and have an angle. Here you have the angle, the side, and the angle. The side is in between. They're attached to the two angles, so it's angle, side, angle. It's just a rotated picture.
So there has to visually be three distinct markers.
Or that you tell me how you're adding a marker into it.
Okay.
Like reflexive, alternate interior angles, vertical angles.
Okay.
So make sure you do that. Garrett, the lines don't mean that those two angles are equal. That's not what that means. It's just they're pointing to them, okay? So those are your degrees of each of the angles. So solve for x, please. Combine the two angles. So 90 equals 7x plus 6. Subtract the 6. And divide off the 7. 84 divided by 7. 12. All right, let's do a proof. Got 4 minutes. Gotta do it fast.
Cooper, can you shut up?
Can you do the fill in the blank?
Good one.
on the trash?
Nope.
I don't
Bro,
know.
please, I'm going in.
Like that, I'll go, wow, this is cool. We'll do one.
You okay?
We can't pass yet.
It wants you to prove that triangle MJK is congruent to triangle KLM. There is nothing on here other than this right here to finish your picture. There's nothing on here marked. That means you got to tell me everything you know because you have parallel lines now. What, right off the bat, can you tell me about the picture?
MK and
Yeah, you have a reflexive piece here. This is in both triangles. So MK is congruent to KM. Reflexive property. All right. So that's one piece. You need two more pieces. All right, so here it is for the sake of time. Parallel, parallel cut by this transversal. That means those two angles have to be the same. Angle JML, or JMK, sorry, is congruent to angle LKM. Alternate interior angles. So now you have two pieces. But you also have parallel lines up here, cut by the transversal. So alternate interior angles are in those positions. Angle JKM and angle LMK. And so now you have the three pieces you need: angle, side, angle. Every proof you have to go through and mark what's needed. And then you look to see what side you have and what angles you have.